Welcome back. Let's look at a second example of union and intersection, this time dealing with sets. So first we'll set up our universal set as the numbers 1, 2, 3, 4, 5, 6, and 7. A universal set are the only numbers that are relevant to the problem. Okay? No numbers outside of 1, 2, 3, 4, 5, 6, and 7 can be counted anywhere in this example. So now, after we know our universal set, I'm going to set up subset A. So A, what does it mean to be a subset? It's part of the universal set. In this example, A is the subset of odd numbers from my universal set. So 1, 3, 5, and 7, those are the odd numbers that come out of my universal set. Set B, I'm going to let B be the first four numbers from my universal set. So 1, 2, 3, and 4. That's what subset B is. So again, U is the universal set. A and B are both subsets. So first, let's go right into union and intersection. I think intersection's a little easier, so I'm going to do the intersection first. I'm going to say, what is the intersection between subset A and subset B? The intersection is, what do they have in common? Where do they overlap? We can see that they overlap right here at number 1, and they overlap right here at number 3. So the intersection between subset A and subset B are the numbers 1 and 3. Okay, for part B, let's talk about, well, what is the union of subset A and subset B? The union, remember, a union takes everybody. So what does that mean? That means that in the union between A and B, the numbers 1, 3, 5, and 7 must appear. But also, the numbers 1, 2, 3, and 4 must appear. Okay? Anytime there's an overlap, we do not list the numbers twice. So in order, A union B, all the numbers from A and all the numbers from B are going to be the numbers 1, 2, 3, 4, and then 5 and 7. Okay, again, where do those numbers come from? Well, 1, 2, 3, and 4 came out of set B, and then 1, 3, 5, and 7 came out of subset A. So together, when I put those together, it's 1, 2, 3, 4, 5, 7. So the union takes everything, all of A and all of B, and we combine them. I'm going to use this example to introduce one more word, and that would be the complement. So the complement of set A can be marked either as A with a tick mark, or you can call it A with a bar across the top of it. So again, this is not or like union, intersection, and an or. This is just two different notations on how you can call the complement, and it is complement with an E, not complement with an I. This is not, ooh, you're so pretty. This is more like peanut butter complements jelly. Okay, so what is the complement of A? What does that mean? Well, first we need to look at set A, and we need to say, okay, the complement are the numbers that are not in A, so not the 1, 3, 5, and 7, but the numbers that are in the universal set that do not exist in A. So what exactly does that look like? Well, if A is the subset of all the odd integers, then the complement of A must be all the even numbers or integers in that set. So the complement of A becomes 2, 4, and 6. If I want to quickly just make sure I can apply that to, let's say, B complement. Okay, so let's again apply that definition of what does it mean to be a complement. So again, we look at B and we see 1, 2, 3, and 4. So I got to go up to U and say, what is left in U that's not in B? Okay, what numbers are there? There are the numbers 5, 6, and 7. So again, what does this mean to be a complement? The complement is basically what completes the set. So what numbers complete set A to get it back to the universal set? In other words, if I were to take A union A complement, I'm going to get the full 1, 2, 3, 4, 5, 6, 7. If I were to take B, union B complement, again, I would get the 1, 2, 3, 4, 5, 6, 7.